Before talking about clean architecture, I'd like to give you a brief introduction to hexagonal architecture, or ports and adapters, which I believe is a better name. So here we can see a graphic representation of what hexagonal architecture is. I took this image from a Netflix blog article. I will leave the link here in the description. But the main purpose of the hexagonal architecture is to isolate the business logic or the core logic of our application from implementation details or external concerns. Let's assume that in our API we need to fetch or collect some data, and for that we're going to use a REST API. So instead of coupling or attaching the implementation details of this API to our application, we can simply create a port which describes the methods and the properties that we will use in our application, independent of which way we will use to collect this data. And in this way, we create a generic abstraction and we will no longer depend on concrete classes. Then we can create an adapter that connects to that port using the REST protocol. In this case, if we need to change to another API that uses gRPC, for example, instead of REST, we just need to create a new adapter for this port that we just created, and we won't need to change the core of our application. We are going to see some practical examples of how to create these ports and adapters, but first I want you to take a look at these two quotes from the same article that I believe that summarize perfectly what I just explained. So the idea of hexagonal architecture is to put inputs and outputs at the edges of our design. Business logic should not depend on whether we expose a REST or a GraphQL API, and it should not depend on where we get data from, a database, a microservice, and so on. The pattern allows us to isolate the core logic of our application from outside concerns. And that's, in my opinion, is the most important part. And having our core logic isolated means that we can easily change data source details without a significant impact or major code rewrites to the code base. It's important to note that hexagonal architecture came before clean architecture. However, they share the same goal, the same objective, which is the separation of concerns. In fact, hexagonal architecture was one of the foundations that Hobbit Martin, or Uncle Bob if you prefer, used to create the so-called clean architecture. The hexagonal architecture lacks some details on how to implement ports and adapters and other details that an application normally needs. And that's where clean architecture comes in, to fill in these gaps. But now, before we get into the clean architecture, let's see how to implement ports and adapters using Typescript. And one of the ways we can do that is by using the dependency inversion principle, the last principle from Solid. And this is kind of a spoiler about clean architecture, but the dependency inversion principle says that high-level modules should not import anything from low-level modules. Both should depend on an abstractions, for example interfaces, and abstractions should not depend on details. Details or concrete implementations should depend on abstractions. This is kind of generic, isn't it? But what exactly does that mean? Let's see. Now, let's suppose that we need to create a new use case to export a user, for example. So let me create a new file here, export user.ts. And let me create a new class here, export user use case. And then you can have an execute method here. And if you're not familiar with the concept of use case, don't worry. We'll take a look on that in more details when we talk about clean architecture. But for now, just keep in mind that this class will be responsible for a user intention. In this case, export a user. And the controller, for example, would be responsible for calling this class and invoking the execute method. So, the most common way to do this is to simply import our npm package, for example, here. For example, let's say import CSV from CSV. This is just an example, and here you can use our package like csv.export, for example. However, by doing this, our code is now dependent of this CSV package. So how can we remove this dependence and make our use case able to accept any kind of export implementation? And the answer is using interfaces. And the interfaces are just the ports of the hexagonal architecture. Do you remember? We have like ports and adapters, and the interface itself is the port. For example, let me create here a new interface. Interface, let's say export user data. And now we can create our adapters, which is basically a new class implementing this interface we just created. For example, let's say export user to PDF. And this class will implement the export user data, okay? And here I have the export method where I can use any PDF package I want to. So now here in our use case, instead of using the CSV package or any other package, we can now define a new dependence in the constructor of the method, in the constructor method. For example, private export user data, and the type of this dependence will be the interface we just created. And here I can use, for example, this dot export user data dot export, and then I can pass my user data. So now, in order to use this use case, const export I need to pass this dependence, and this dependence is basically the instance of my adapter. For example, the export user to PDF. Okay, and now I can call the export user dot export execute, and here I can pass the name, the email, and the date of birth. This way, if I want to implement a new logic to export my user, let's say that I want to use a CSV instead of PDF, I just need to implement a new adapter here. In this new adapter, just need to implement my interface. For example, CSV. And here I can use any CSV package I want to, or do whatever I want to do here. And now, instead of creating the export user to PDF, I can create a new instance to export user to CSV. And since this adapter is implementing that interface, I just need to pass this new adapter here, and now I'm fine. So you see, I could change my implementation from the PDF to CSV without touching the business logic here and here. And that's the point, that's the main goal of the hexagonal architecture, and this is how we can do that basically. So I hope this helped you to understand how we can make our code less coupled and how we can create ports and adapters using this dependency inversion principle, creating interfaces for every implementation details and always depending on interfaces, not concrete classes. So now, given this introduction, we can start to get a better look at what clean architecture is about. Okay, so now that we have seen how to create ports and adapters and how to use the dependency inversion principle, we can now start to talk about clean architecture. And the clean architecture basically is an attempt at integrating many architectures into one single idea. As you have seen, hexagonal architecture and many other architectures share the same goal, which is the separation of concerns. And they all achieve this by dividing the software into layers. And the clean architecture defined for us 4 main layers, even though we can create more layers if we want to. But these are the 4 main layers that the clean architecture defined for us. And let's take a look at them, at those layers. So the first one is the entities or the domain layer. It's basically where we are going to define our business logic, okay? It's the most stable layer, which means that we won't change this too much, or we shouldn't change this too much. And it's basically the heart of our application, okay? And this is where we can apply some domain-driven design patterns. If you know domain-driven designer, this is where we are going to apply most of those patterns, like aggregates, entities, domain services, value objects, and so on. It's a layer that is isolated from outer layers concerns. For example, we cannot import anything about use cases or any adapter inside this layer, okay? It's a layer specifically for business logic, so we're going to create our entities there and all the business logic related to those entities, but we're not going to use any other external tool, okay, and any other use case, and just the business logic itself. And one aspect that's very important to mention is that the clean architecture entity is a different thing from the domain-driven design entity, okay? Entity here, it's a layer, okay? And if you go to the definition of domain-driven design entity, we can see that it's a completely different thing, even though we can use the entity inside this layer. And actually, we are going to do that, and it's pretty common, okay? And the other layer is the use cases, and basically this is where the application business rules lives. So, and this is the user intentions or the user actions, for example, create user, export data, delete product, create product. And we're gonna use like interfaces to interact with the adapters, for example. And also we can use the entities. For example, we can use, in this example here, we just have seen, we can create a use case to export a user, and we're going to use this interface to export the user, okay? But we are not going to define any implementation detail here. We are just going to use the interfaces, okay? And yeah, like I said, it's isolated from the details and implementation of outer layers, such as databases and CSVs, export, or any other external detail, okay? And as I said, we just hold interfaces in these layers, and we use something called DTO, which is data transfer object. For example, here, we are using the user data, and the user data itself is a DTO or a data transfer object, but you can also, if you want to, like define a type for that, and this can be used by other layers as well. But the idea in these layers is to use interfaces and DTOs to interact with other layers, okay? And one last thing that's very important is that each use case must be independent. which means that we're not going to create a gigantic use case and put all the use cases there. No, we're going to follow the single responsibility principle, okay? The first principle from Solid, which basically says that each layer, each file, each class in our application must be responsible for one single thing, you know, we have one single responsibility. And here, for example, you can see that we created export user use case. And in our application, let's say that we need to delete the user. We're going to create a new class called delete user use case, and so on. Okay, it's pretty common when you work with MVC pattern, for example, define something called user controller, and then inside the user controller we usually create the create method, the update method, and then the update password, and so on, you know. And this will create a gigantic very big controller, and we're not going to do that, okay? We're going to follow the single responsibility principle, and we're going to define one single class for each one of these use cases, okay? And the other layer is the infrastructure one, which is basically where we are going to define all the adapters of our application. For example, the export user to PDF, the export user to CSV. It's also in this layer that we're going to define the repositories to interact with our database, for example, and so on, okay? So this is the layer where we're going to define the adapters. And the last one is the frameworks and drivers. Basically, we don't write too much code in these layers. It's just a layer for the framework for the database itself, and we don't write much code in this. Actually, if you're using, for example, something like Nest.js or Adonis.js, or if you came from a PHP background, the Laravel and all these frameworks, and we don't write too much code in that usually, okay? And another thing that I want to mention is that we are not restricted to these 4 layers. We can create how many layers we want to, okay? However, and this is very important, we need to apply the dependency rule for all those layers, okay? And that's very important, because basically the dependency rule says that nothing in an inner cycle can know anything at all about something in another circle, okay? For example, in our entities here, we cannot use the use cases here inside the entities. We cannot use the adapters or anything else inside the entities, okay? However, in the use cases, we can use the entities because we are pointing inward, you know? And the same way for the adapters. In the adapters, you can use the entities, for example, because we are going to define a controller here, and this controller will be responsible for calling these entities, and these entities will use, the controller will be responsible for calling the use cases, and the use cases will use the entities, for example. However, we should not in any situation call the use cases inside entities or the controllers or any adapter inside the use case, you know? And that's the dependency rule, and it must be applicable to any layer of our application. We're going to see some real examples of that, but basically we can do that, we can achieve this by using the last solid principle, like we have seen, the dependency inversion principle, where we can basically creating a interface, and we're going to use this interface to export the data in this case or anything else, you know. And this way is how we can achieve this dependency rule, because in the export use case, export user use case, we need to call some way something to export the user, you know, something that we use some package or something external. And we can do that by creating an interface, okay? So this is all I have about hexagonal architecture and clean architecture. I recommend you to take a look at this blog post here from Uncle Bob. And a fun fact is that everything about clean architecture is inside this blog post here. Okay, you probably know that Uncle Bob has a book called The Clean Architecture. However, all the pages in this book that mention clean architecture are here inside this blog post. It's basically a copy and paste. So I'm not saying that you shouldn't read the book. If you have the opportunity, I recommend you. But it's important to know that everything there is inside this blog post. Okay, so here you can see that it mentions the hexagonal architecture. It has a description about the Dependency Rule and also about the dependence inversion principle some way. Yeah, and it also has a description about all these layers, you know, the entities, the use cases, interface adapters, and so on. So I recommend you to take a look on this blog post. I'll leave the link in the description. And in the next class, we're going to start our application, and we're going to see how to create the entities and the use cases and how to create unit tests for that. Okay, so see you there.